I would like to thank all our panelists to come to the stage, and also before moving to the part of questions, I would like to give 3 minutes to each of you to give introduction and also a presentation of your company. So please, Nicola, could you go ahead?
Okay, Nicholas van Dijk. I am the CEO of Ort Energy. So Ort Energy are a next generation PEM electrolyzer company. Okay, so we delivering products today. What do I mean by next generation? We have solved a key problem to do with hydrogen crossover, which means that we can make membranes thinner, so therefore we can increase performance, and we can also do high pressure electrolysis. Fundamentally, our mission is all about driving down the cost of green hydrogen. Ultimately, we want the market to drive the change needed. The climate problem is huge, and it's only going to be driven when the market, when people make the change, because it's the best one to do by the market. Can we put the next slide up? So we have 3 key pillars that allow us to drive down the cost of hydrogen. We're focused primarily on the stack technology, okay, but we still build the complete balance of plant. We do it in a slightly different way to most others, but we still build the balance of plant, the full complete hydrogen system. But the stack technology that you see on the picture there is a 250 kilowatt PEM stack. It's a modular system, okay, designed for mass manufacture from the word go. We've eliminated all types of engineering, like CNC type engineering, so it's designed for mass manufacture. You know, we need to turn the hydrogen industry from an aerospace type technology to an automotive type technology. That's how we're going to drive down the cost. And so that means designing from the outset. We also have a low-cost bipolar plate coating, really, really important for increasing lifetime, and we have an innovative, really low-cost bipolar plate. Durability is a difficult thing to study, but we have solved the mechanisms and we've driven down that cost. And the third thing, of course, as I mentioned, is by stopping this hydrogen crossover, we can really increase performance. So we are driving down cost and driving down both CapEx and driving down OpEx. Thanks.
Thank you, Nicola. So now we will move to Ravi. Please, could you introduce yourself and a little bit your company in a few words?
Yes. Can you hear me? Yes. So thank you for having us here. So I'm the Chief Technology Officer of Bloom Energy. First of all, Bloom Energy as a company is a publicly traded company. We are operational in many parts of the world and expanding quite a bit in Europe and Asia and other parts of the world. We have roughly $1.3 billion in revenue. We make both fuel cell and electrolyzers, and I'll show you later on in one of the slides that we use a common platform and common manufacturing plant to do both the fuel cell and the electrolyzers. We've had around 1,200 installations, and we have roughly $12 billion in backlog. So the scale at which we are operating gives us a unique advantage in terms of deploying very large-scale electrolyzer projects. In terms of the technology, unlike PEM or alkaline, which my colleagues will talk about, we are a high-temperature platform. Our system works at 750 degrees Celsius. A biggest advantage of having a high-temperature platform is that we do not have to use exotic catalyst materials like iridium. And that's one of the big advantages in terms of materials and supply chain. Go to the next slide. So this is solid oxide electrolyzers. This is the largest demonstration conducted in the world. This was done at our NASA Moffett site in San Francisco Bay Area in the United States. And this plant is still operational. We are producing more than 2.5 metric tons of hydrogen today as we speak. One thing which I would like to point out that this technology has also been tested by Department of Energy's National Lab, which is called Idaho National Lab, which is run by US Department of Energy. And they have been asked by Department of Energy to compare various technologies, both low temperature and high temperature like ours. And what they have found out that Bloom electrolyzer is the most efficient electrolyzer they have ever tested so far, roughly 20 to 30% more efficient than low temperature electrolyzer systems. Go next slide. As I mentioned, we also make fuel cell. So if fuel cell is basically you put hydrogen in and you get electricity out. In the electrolyzer, as we know, we put electricity in and we get hydrogen out. The platform is exactly the same with very minor changes, as you can see on the slide there, that all the way from the cell to the stack to the actual system, very tiny variation happens at some of the layers, and then we use the same platform, and that enables us to use the same manufacturing facility. Right now, we can make roughly 2 gigawatts of electrolyzers, and we have the capability to expand this facility up to 7.5 gigawatts a year. Thank you very much.
Thank you, Ravi. Please, Mathieu, could you please introduce yourself and the company?
Thank you, Noaya, and thank you for inviting me to this panel. John Cockerill is a company that has been founded 200 years ago in Belgium. We have 6,000 employees worldwide, which is quite a big number of employees for an electrolyzer manufacturer. We also provide engineering services and projects towards energy transition. So this is globally the purpose of the company, the aim of the company. We came to the hydrogen 7 years ago, so quite recently, by making the acquisition of pressurized alkaline electrolyzer manufacturer. And thanks to this, we have now a factory in China already operating 1 gigawatt, manufacturing 1 gigawatt of electrolyzers per year. And we also, very recently this year, started operating our factory in Europe, which is a factory split between France and Belgium. So very substantial and important moves to the hydrogen the past years. And I would start, and I would just want to finish by highlighting the fact that John Cockerill is also locally very present in Morocco. We have John Cockerill Morocco established here since 10 years, providing services to the industrial players locally, and that's a very important differentiator on the market today when at the moment where we want to offer our electrolyzers locally.
Thank you, Mathieu. Please, Hajar, the floor is yours.
Okay. So I'm presenting Mazen, which is the focal point in charge of the Morocco offer. As per the circular that has been published in the beginning of this year. So yeah, I can give more details afterwards if you want.
Thank you, Hajar. So thank you all for the presentations and also for the introduction. Now we will tackle the part of course, questions. Since we have a panel discussion, it's always good to have such a dynamic session. So we'll start with Nicola. So we know that URT, as you have also presented, is a key player in PEM electrolysis technology. So what are the most significant technical challenges when scaling up electrolysis in industrial?
So I'm going to start by saying, and every time we talk about scaling up electrolysis, I always start with the keywords that a FEED study, front-end engineering design study, is key to getting it right. Okay, and I'll talk a little bit about that and what I mean by that in a minute, but it's really important that we get the specifications right from the word go. The second thing I'm going to say is, to a first approximation, and it is a first approximation, But if we take the stack technology out of it, almost all type of electrolyzers have a modular stack system, okay? And whatever the size of that module is, it's different between companies, it's different between technologies, but it's some sort of modular stack. So actually, in scaling up there's not really a technology barrier per se. I mean, there's lots of things we can do to make things better, but actually in scaling up the individual stack technology, which is the difference between the electrolyzers, it's the electrolyte essentially, there isn't a thing. But every single electrolyzer in the world, to a first approximation, has the same balance of plant. Okay, so they need to turn AC into DC, high voltage AC into DC. They need to purify water. They need to take the water out of hydrogen and, if possible, recycle that water. They need to manage the hydrogen. They need to manage the oxygen stream. So all of these things are fundamental to, and there's a heat management system in all electrolyzers as well. So to a first approximation, all of these are the same for every electrolyzer. Now, scaling it up, actually, a lot of these components are brought in. Power supply units are brought in, water purification systems are brought in, and actually getting alignment and scale of between different partners, is really, really key when is a key technical challenge when scaling up electrolysis. Everybody's got to deliver at the same time, okay, and everybody's got to deliver to the same specification, okay. The second thing is, once we start getting up to really large scale, managing inputs and outputs are key, because, and that's all really about storage. Now, at a small scale, a few tens of megawatts or a few single megawatts, actually storage is not that much of a problem. But once you start getting up to hundreds of megawatts or gigawatts, storage is a very, very difficult thing to do, but at that large scale, and actually that's really needed to manage supply and demand. If we're going to turn green electrons into green molecules, and green molecules all start with green hydrogen, doesn't matter whether you're making ammonia or methanol or whatever. Actually, sustainable aviation fuels, another big area at the moment, but actually managing that key between supply and demand is absolutely key. The other technical challenge, I think, when scaling up is all about managing the sorry, I've lost my train of thought there. It's all about managing the specifications up front, okay? Actually, the people that purchase electrolysis are not the site managers or the project managers, and actually specifications always outweigh commercial. They always supersede the commercial requirements. So getting those right up front is key. We've all got to work with EPC partners to manage these things, but EPC partners are a little bit like lawyers, and actually they love deviations, and deviations cost money. So minimizing that from the word go is really, really important when trying to scale up the electrolysis.
Thank you, Nicolas. So we understood that the main challenge for scaling up the electrolysis is relying on having kind of a synergy between all technological blocks of hydrogen systems, and of course this is the integration. So talking about integration, we will move now to another technology, which is bloom energy technology. So that has been at the forefront of developing SOEC technology. So how can this technology be effectively integrated with renewable energy like, of course, solar and wind?
Okay, thank you. First of all, I want to say something that Nick said, which I totally agree, that irrespective of the electrolyzer technology, whether it's alkaline, PEM, or solid oxide. The balance of plant, rest of stuff, rectifiers, compressors, pumps, all of those things will remain same, okay? So the cost of rest of the plant doesn't matter what technology you choose as electrolysis technology, that will remain the same, right? So there's a lot of commonality there. Coming back to Bloom's technology, so in our electrolyzer at high temperature electrolysis, instead of putting water, you put steam, okay? So any process where you can get the steam for free or very cheap is a natural fit for our technology. So ammonia in particular is a very, very good fit for solid oxide technology, because if you look at ammonia, well-known Haber-Bosch process produces a lot of heat. And you can use that heat to make steam, so you're getting steam for free, and integrate it with the electrolyzer, right? And then you can continuously feed that steam in the plant. So that basically means that you're going to be able to save roughly 20 to 25% of electricity cost, because you don't have to convert that water into, even you're doing low temperature, if you go back to the chemistry, you're breaking two types of bonds, hydrogen bond and covalent bond. When you do steam, you don't have to worry about the hydrogen bond. That's the physics of it. Now coming back to, so that's one. Ammonia is a very, very good fit. But if you look at a lot of industrial processes, whether it's steel or other chemical processes, a lot of these processes have a lot of extra heat available, waste heat available. And that is where I feel that solid oxide is a very natural fit in those situations, right? And I want to say, right, I mean, we have other technologies here. Every technology has a role to play. Somebody comes and says that one technology will completely dominate the market, that's not right. Okay, there's certain technology, there's certain traits each technology has, they have a role to play. In our case, particularly for ammonia, steel, other chemical processes, we are a very, very good natural fit. So integrating with those plants and then really understanding how the overall system operates is very critical. But going back to the earlier question that you asked, technological barrier, again, I'm going to go back to what Nick said. If you look at the stack of various technologies, they're all modular. I just fundamentally, a modular technology can scale if there is volume, right? You don't see any, difference. It's not like a typical chemical plant where a smaller plant will be less efficient and larger plant will be much more efficient. Challenge has been that how do you create the demand, right? So that I would say is, even in earlier sessions in the morning, that's what I heard from many of the panelists, that the whole world has been waiting for the demand creation. That if you make ammonia, if you make that hydrogen, if you make e-methanol, who are going to use it? Who are the buyers? And that will automatically lead to significantly solving a lot of integration challenges by connecting the electrolyzer with the rectifier or a compressor or a pump, seeing how it goes up and down with the renewable energy. And then finally also integrating with the end industry like ammonia or steel.
Thank you, Ravi. Of course, many parameters are influencing the integration of each technology. And of course, we have different applications, so the different technologies could be applied with each application. So now coming to John Cockerill, we know that John Cockerill has a strong presence in large-scale electrolyzer manufacturing. So for you, Matthew, what are the key learnings that you have gathered from large-scale deployment projects?
Thank you, Noeda. Yes, John Cockerill is, as I was saying before, John Cockerill has a huge experience in large-scale electrolysis. We are manufacturing pressurized alkaline electrolyzers since more than 30 years. We have, I think we did not see my slides initially, but there was a key figures showing that we have, for example, more than 600 megawatts of electrolyzers in operation worldwide, which is very huge, very important on this market. We also have 80 units of our flagship 5 megawatt stack already delivered and in operation worldwide. A lot of them are located in Asia, but with the opening of our new factory in Europe, we will also have very quickly references here in Europe and in Africa. Speaking of large-scale electrolysis, it's very important also to mention that we have been involved in two major projects above 100 megawatts. We delivered and they are in operation in China, which is key for our learnings and key for providing to our engineering team and to our research and development team the gold, what we call the data. And thanks to this, we have a lot of information, a lot of feedback that enables us to make our solution moving, make our solution evolving with the needs of the market. Indeed, and I agree with my colleagues, one of the key points is when we speak about large-scale electrolysis is to get mutualization. What is mutualization? Is the fact that, for example, the so-called balance of plant, we need to mutualize all what can be mutualized in order to improve the CapEx, improve the OpEx, indeed to make it smartly to avoid losing some availability on the plant. But mutualization is key to reach an effective price on the CapEx. So we will go on mutualizing the PCUs, we will go on mutualizing the separation skid, provided that our flagship 5 megawatt stack, as I was mentioning, remains at 5 megawatt for the time being. I will maybe have time to further discuss on this later. So the first point for me of the key learnings of the large-scale deployment is mutualization and is going bigger. Very important for the project itself. Another very important learning, and it's something related to what we all meet in life, is facing difficulties make you better. And we all know that electrolysis today is, let's say, even if we have 30 years of experience, we are now in going to large scale, and we are facing new challenges, new adventures that we never met before. And facing difficulties enables us, and that's what we saw on the project on the large scale project that we had the opportunity to start up and commission. Facing difficulties makes us moving. And we had a lot of learnings thanks to these two big projects, for example, related to intermittency, feeding the electrolyzers, feeding pressurized alkaline electrolyzers. So, you know, the so-called turn down, the hydrogen to oxygen, well, a couple of topics related to process. We faced issues, we faced difficulties, but we made it a chance to fix the solution, to fix the problems, to find solutions. And the good things over this, thanks to this, is that we are implementing the solutions we found in our design. So our design is also moving on a continuous basis, integrating the solutions that we found on the site itself, on the plants that we had the chance to commission.
Thank you, Mathieu. So we agree all that to succeed the scale-up of all technologies, we need kind of a harmonization or mutualization, as you said, of all the technological blocks. So now moving to Hajar from Mazen. So we know that Mazen is also occupying the portfolio of renewable energies in Morocco. And also now they are the main coordinator of the Moroccan hydrogen offer. So could you please emphasize more about this offer?
Yeah, for sure. So as you all know, there was an official announcement on March of this year where the Moroccan government presented its Morocco hydrogen offer for the development of the green hydrogen industry. And a circular has been published as well by the head of government to setting out a framework of incentives and support to the project holders and companies looking to invest in this field. So this offer applies to what we call integrated projects. since in Morocco we have the opportunity to host the entire value chain from the production and generation of renewable electricity, production of hydrogen by electrolysis, and all the processing and transformation into derivatives. So the Morocco government identified significant public land based on 1 million hectares with a first phase of 300,000 hectares that will be allocated to this project and that are ready for immediate development. So our mission is to ensure at the end the responsible and the good use of this public land. And the offer aims as well to the development and construction of shared infrastructures, so the water desalination plants, the transmission lines, the road access, and so on. So at the end, you will have access to the land, to water, to infrastructure, and this is the best solution to de-risk a hydrogen project and make it bankable. So regarding the role of Mazen, we are a focal point, and this was a key decision taken by the government to say that we need someone, one focal point is like one-stop shop to ensure this orchestration role. So Mazen has received so far 40 projects proposal from both national and international developers, and these projects are covering all the regions of Morocco from the north to the south. So the process is ongoing, and we are very honored to participate to this mission.
Thank you, Hajar. So the Moroccan hydrogen offer is it's a really key driver to the investors and the project developers for large-scale hydrogen projects. And of course, we'll be very enthusiastic to know more about what will be the results and what will be, of course, the project that will be selected. So coming back to to PEM technology, so what are the key lessons learned for large-scale electrolysis project that can, of course, inform future developments?
Let me start with the same comment, that feed study is key. And let me give you a somewhat trivial example about what I mean by that. We are working with a company now that has a requirement that all wiring trays need to have 20% spare capacity. Okay, it's easy to do. Actually, it's no problem to do that at the design stage. It's much harder to do that, particularly at large scale, once you've started building. Okay, so getting that feed study up front is really, really key. We had the pleasure, I guess, of being able to develop, build, and deploy the UK's very first completely off-grid hydrogen electrolyser. Actually, that's taught us huge amounts about directly coupling hydrogen to renewables. It's in the UK, it's solar. UK is not known for its solar spectrum. It's not quite the same as here in Morocco, but so that comes with its own challenges, okay? And it comes with a number of challenges. We all think about, directly coupling, and I think most of us would believe that actually hydrogen needs to be directly coupled to renewables, behind the meter to be able to drive down to get the lowest cost electricity and drive down to get the lowest cost hydrogen. But actually, once we start to do that, it comes with, we all think about the challenges of, what happens when the sun goes down, what happens when a cloud goes over the sun. But actually, this is a real working environment. And there are times when a bit of equipment turns on, and actually the electricity or the management system has to divert that electricity to run the manufacturing plant rather than produce hydrogen. Okay? So we need to be able to turn off and on extremely quickly. We need to know when to turn down pumps and when not to. Okay? It's easy to think about at the start and the end of the day. And also, it starts to define our strategy for how we develop long-term, much larger systems so that actually we can really capture that whole spectrum, okay, right at the start and the end of the day. You know, electrolyzer systems, depending on where you are in the world, you know, you don't want them to freeze. Okay, I think pretty much I'd agree. Most technologies you wouldn't want the electrolyte or the solution to freeze. And so therefore there are certain challenges when it comes to completely shutting down systems, particularly in Northern Europe where we have much more colder winters. You know, here in Morocco it's probably not such a thing, and so therefore management of that when the sun is not shining or the wind is not blowing is much easier. So the other key learnings we have from scaling up are starting to think about some of the roadblockers along the way. You know, many years ago, I was in a field. I've spent most of my career in energy storage, and I was doing large-scale energy storage project, and this was a 200 megawatt-hour flow battery, and actually so it's a different technology, but it has the same kind of scale-up challenges. You know, we had to think about what happens if a plane flies into it. Okay, it's something we don't ever think about, but once you start getting into large-scale, government-level type infrastructure, there are a lot more different challenges that you really need to take into account when you are designing these systems. So you have to design for large scale. The other thing that actually can sometimes happen because it is at government level, sometimes there are certain procurement type or certain government things that are imposed on you as a developer or somebody else, but certain things that actually can make it very difficult. Again, a somewhat silly example is you know, requiring 3 quotes for all types of infrastructure. Now, actually, that's completely sensible as long as you get the specifications right. Because if you don't get the specifications right, then you can then somebody can always undercut somebody else, and a government can require you to use that contract, okay, even if it's not the component you want. So getting those specifications are key. The other thing that we've got to be very careful of when scaling up is thinking about I talked a little bit about supply and demand before, but thinking about alignment, and I talked again before about talking about alignment of all the key parameters or all the key players. Okay, not everybody has the same deadlines. Okay, and actually not everybody has the same warranties. Okay, so it's actually, once we start scaling up and we start financing large-scale projects, and I'm talking about 100 megawatt plus type projects here, you know, the financing needs warranties and guarantees. And actually, when you are using many different suppliers, who warranties the whole system? And that's, again, a key challenge for scaling up any type of electrolysis, actually.
Yeah. Thank you, Nicolas. So beside, of course, beside other challenges, certification is very crucial challenge. So coming also now to Ravi. So how are you addressing the challenges of scaling SOEC, electrolysis, in terms of manufacturing, supply chain, and operational readiness?
So fortunately for us, as I showed earlier, right, the platform is the same, fuel cell and the electrolyzer. Very minor change, very tiny. So in that sense, we feel that the ability to scale, depending on the demand, of course, is not going to be a problem for us, okay? So I don't think the challenge is going to be scaling the electrolyzer itself. Again, I'm going to go back to this, it's a chemical plant at the end of the day. You're getting electricity and then finally you're getting hydrogen. In fact, you're getting ammonia probably, most likely, because you don't have hydrogen storage available at scale today, which is economical, right? So you have to look at end to end when we talk about scaling, right? Electrolyzer is very key. It's like I call it this, the electrolyzer is the heart, but you need the rest of the body for this whole thing to function. You need the hands and the legs and everything, okay? Even the heart is the electrolyzer. So when we talk about scaling, really, I would say any project developer, even government, has a big role to play anywhere in the world for this new hydrogen economy to take off. We should look end to end, right? For example, right now, if you go and talk, they'll say hydrogen compressors have a huge supply chain problem. It will take 18 months, give or take, okay? So then again, you can be ready, but if you cannot compress, then there's a problem, right? So that's why I say that end to end is very, very important. And I also think, looking purely from infrastructure point of view, right? That if we make ammonia, how is the shipping going to take place? Which ship is going to take ammonia? How are you going to unload that ammonia at other place, right? So all those things become very, very important, right? In terms of green hydrogen economy to take off. I honestly feel that as electrolyzer, doesn't matter our electrolyzer or PEM or alkaline, they're ready. I just feel that it's a modular technology. You just copy and paste the same thing. It is other parts which needs to be really, all the other pieces of the puzzle have to fit together. And I would say that all the electrolyzer manufacturers are ready to go.
Thank you, Ravi. So, of course, the main challenge for manufacturing is we have kind of a bottlenecks for the whole supply chain of electrolysis manufacturing. So coming to John Cockerill and also always in the same topic about manufacturing. So can you please, Mathieu, provide some insights into the collaboration between manufacturers like, of course, John Cockerill and partners to accelerate the industrial deployment of electrolysis technologies?
Yes, GC is still working very hard on its technological deployment and on the industrial deployment. That's a key point. I mentioned the factories that we have in China and in Europe, and we are also involved in projects in US and in India also. So it's a very strong and robust roadmap. Deployment in different geographies, and for this we need definitely to find solid partners to support us on technological side, but also on financial side, and it's a key element. And for this, we have been able. 2024 is key for us regarding this topic because we have been able to secure two main partnerships. One was announced on the market earlier in January, having the creation of the joint venture called Rely. Rely is a joint venture between Technip Energies, famous EPC on the market, and John Cockerill, with purpose to create an EPC contractor able to provide integration solutions, standardized hydrogen and power-to-X solutions, so that to make large-scale projects to produce hydrogen or also to produce ammonia or methanol or this kind of thing. So it's a first step of our partnership and deployment worldwide with a strong association with Technip Energies. Second partnership that we were very happy to announce on the market this year was just before summer. we have, and this was related to the fact that to support this strong deployment, we need to find also financial partners. And we had the pleasure to announce that we were having a new shareholder inside John Cockerill Hydrogen with the company Schlumberger, SLB, American partner, having a strong presence on the market, on the oil and gas market. And together with SLB, we will also be able to support joint technological deployment. We will find some additional solutions on the market to find new solutions on electrolysis, to improve our solution for alkaline technology, but not only, we will maybe be able to find additional improvements and additional technologies. So these are the two main moves and partners that we were able to secure and to support our strong deployment. And in parallel of this, which is already done, we are still discussing on other geographies to support our deployment worldwide and also in Morocco. And we are involved in discussions to see what we can do here on the market, not only to install and commission our electrolyzers on the market, but also, why not, to manufacture it on the country. So that's a big challenge and a new adventure that is coming for us.
Interesting. So congratulations for all the partnerships you are undergoing. Now moving to Mazen. So please, Hajar, what are the challenges that you see for the deployment of hydrogen large-scale projects and the implementation of the Moroccan hydrogen offer?
Yeah, for sure. There's still challenges on the technical and financial side as well. Because as you know, we are coming from a world dominated by small-scale, megawatt-scale projects that are mainly financed by grants and subsidies. So we are lacking experience and feedback on how to finance these projects, large-scale projects, and as well on the technical side, we how to operate safely and correctly and gigawatt scale electrolysis plant. So we need in Morocco to train people and future operators to operate gigawatt electrolyzer, because you are handling huge quantities of pressurized gases. So you may have some safety concerns to deal with. And the same for the ammonia. So you have to, ammonia and hydrogen as well have to be handled with extreme care and caution. And we are still lacking as well a clear regulatory framework in terms of norms and standards to be applied to this project. The second challenge that I'm seeing is the supply chain constraints, given the scale of the project that we will have in the country. When it comes to solar panels, wind turbines, and electrolyzer, and especially electrolyzer, since the manufacturing capacities in the world are limited. For sure, they are growing and increasing thanks to the incentives like IRA in the US, and most of these factories are becoming more and more automated. So the manufacturing capacities are increasing, but the demand as well are increasing, which is a good news, but we need to reduce the risk of procurement issues that we can have on these projects. And this is an open invitation to manufacturers and vendors who are present here since you are spending some time in Morocco, to explore opportunities with stakeholders and developers to study the opportunity to localize manufacturing capacity of electrolyzer in Morocco. And one of the challenges that I'm seeing as well is the infrastructures. So Morocco need to upscale the infrastructure to to fulfill its potential. Yeah. So this is the main challenges that I'm seeing right now.
Thank you, Hajar. So as we are a little bit running a bit over the time, we will not be able to collect some questions from the audience. So I would like to thank all our panelists, and please hot applauses for our esteemed panelists. Thank you. We can take a photo if you want.